Welcome to Windows Forensics Chapter 8. This is Professor T. Farid Muhammad. We will be learning in this lecture about various types of digital forensics that apply on Windows. Windows details, evidence in volatile data, Windows swap file, Windows log and directories, Windows registry. Microsoft Windows Forensics is a branch of digital forensics that focuses on investigation and analysis of Windows operating systems and associated artifacts to gather evidence, often in the context of legal proceedings or incident response. The primary goal is to identify, preserve, and interpret digital evidence in a manner that is legally admissible and can help reconstruct events or activities that occurred on a Windows system. The history of Windows is Windows 3.x, Windows 95 or NT, Windows 98 2000, Windows XP Server 2003, then Vista came, then Server came in 2016, and Windows Server in 2019 came. One of the key aspects of Windows forensics that we'll be looking into in little depth is the examination of the file system. Windows uses NTFS, New Technology File System, by default, which includes various metadata and structures that can provide valuable information. Forensics analysts can examine file timestamps, ownership, permissions, and even deleted files using tools like FTK, Forensic Toolkit, or NCASE. We have discussed these in quite depth in previous lectures. Additionally, the master file table MFT in NTFS is a critical component that stores detailed information about every file and directory on the volume, making it a rich source of forensic data. Another crucial area of Windows forensics is the analysis of system and application logs. History of Windows is Cortana, Edge Browser, Universal Apps is Windows 10. Issues pertinent to forensics. Does the Windows version in question support 64-bit processing? Does it have a firewall? If so, is the firewall automatically on? Does the version of Windows support the encrypted file system or EFS, which allows the user to encrypt specific files and folders? Windows event logs, for example, can capture a wide range of activities, including system events, security events, and application-specific logs. These logs can provide insights into user activities, system configurations, and potential security incidents. Tools like Log Parser and Event Viewer are commonly used to extract and analyze these logs. Furthermore, the Windows registry is a hierarchical database that stores configuration settings and information about installed software, user preferences, and system hardware. Forensic analysts can examine the registry to uncover evidence of malicious activity, such as unauthorized software installations or changes to system settings. The 64-bit processing, this starts with 32-bit, addresses up to 429496729 bytes, limited to 4 gigabytes of RAM, referred to as x86. 64-bit addresses up to the number given on your screen, referred to as x64. Basic input-output system or BIOS has post, read MBR, bootloader, loads NTLDR, switches to 32 or 64-bit. Boot files are min.drivers, boot.ini, and NTOSKRNL or kernel. Important files are ntdetect, ntbootd.sys, NTOSKernel, HAL, and all the list is given for you to review. The NTFS file system has all these. Let me share with you a little bit more in depth about NTFS file systems. NTFS, or New Technology File System, is a proprietary file system developed by Microsoft and used primarily in its Windows operating systems. It was introduced with Windows NT and has been the default file system for Windows since Windows XP. NTFS offers several advanced features that make it important for digital forensics, including enhanced security, data integrity, and rich metadata. Understanding the structure of the features of NTFS is crucial for digital forensics investigators for several reasons. Firstly, NTFS is designed to store a wealth of metadata about files and directories, which can provide valuable context and evidence in forensic investigations. This metadata includes timestamps such as creation, modification, and access times, file ownership, and permissions. These attributes can help investigators track file activities, identify users involved in specific actions, and detect anomalies that may indicate unauthorized access or malicious behavior. For example, discrepancies in the timestamps can suggest file tampering or system clock manipulation. Secondly, NTFS uses Master File Table, or MFT, to keep track of all files and directories on the volume. The MFT is a critical structure for forensic analysts because it contains detailed information about each file, including its attributes, data runs, pointers to the file's data on the disk, and even remnants of deleted files. By analyzing the MFT, investigators can recover deleted files, examine file history, and uncover hidden or obscure data. Tools like FTK and NCase, as we discussed earlier, can parse the MFT to extract the present and present disinformation in a usable format for analysis. NTFS supported advanced features like alternate data streams ADS, for instance, allows files to have multiple data streams which can be used to hide data or execute malicious code. Understanding how these features work and how to detect and analyze them is essential for forensic investigators. For example, malware may use ADS to conceal its presence, and knowing how to uncover and examine these streams can be crucial in identifying and remediating security threats. Fourthly, NTFS includes several mechanisms for data integrity and recovery, such as journaling and file system repair tools. Journaling helps maintaining file systems consistency by logging changes before they are committed to the disk. This can be useful in forensic investigations to track and the changes and recover data in the event of the system cache crash or power failure. Additionally, tools like CheckDisk, CHK, DSK can be used to repair file system errors and recover data, although their use in forensics should be carefully considered to avoid altering evidence. A deep understanding of the NTFS file system is vital for digital forensic investigators. Its rich metadata, advanced features, and data integrity mechanism provide wealth of information that can be crucial in tracking users' activities, detecting security incidents, and recovering evidence. By mastering the intricacies of NTFS, forensic analysts can more effectively investigate and resolve digital crimes and incidents. Stacks and heap is another area. Stacks are allocated based in the last in first out, most dynamic area of memory process. Heaps are the data can exist within the function calls as well. I would suggest you to look into this to learn more in your given material. The tools are PS lists, processes, PS info, operating system details, list DLLs or load DLLs, PS logged on, login information, and netstat network connections. PS list looks like this. PS info looks like this. List DLLs looks like this. PS logged on looks like this. Windows swap file. So let's look into this with an example. In a digital forensics investigation, analysts can be tasked with determining whether the sensitive corporate data had been exfiltrated from a compromised Windows workstation in a given organization. The initial suspicion arose from unusual network activities detected by the organization's intrusion detection system or IDS. To gather more evidence, forensic team decided to analyze the Windows swap file, also known as pagefile.sys, which is used by the operating system to temporarily store data that cannot fit into the physical memory or RAM. Upon capturing the memory dump and the swap file from the suspect workstation, the analysts used forensic tools like volatility and bulk extractor to examine the contents of the pagefile.sys. The swap file can contain remnants of data from various processes, including fragments of documents, emails, and even encrypted data that was temporarily swapped out of RAM. By searching for specific keywords, file signatures, and patterns related to the sensitive corporate data, investigators aim to identify any traces of unauthorized access or data transfer. During the analysis, the forensics team discovered several fragments of confidential documents within the swap file. These fragments matched the sensitive data and was suspected to have been exfiltrated. Furthermore, by correlating the timestamps from the swap file with the network activity logs, and analysts were able to establish a timeline of events. This timeline revealed that the sensitive data was accessed and likely exfiltrated during the specific time window. Coinciding with the unusual network activity detected by the IDS. Based on these findings, the investigators could provide concrete evidence of data exfiltration, helping the organization take appropriate remediation action and legal steps against the perpetrators. This use case highlights the significance of Windows swap file analysis in digital forensics, particularly in investigating data breaches and unauthorized activities. Volume shadow copy, a Windows service that keeps a record of or copy of state changes, stores state changes in blocks of data that are compared daily. Changed blocks are copied to volume shadow. Volume shadow copy service runs once per day. Windows log files. The security application system forwarded events, application and services, files that contain information about events and other activities that occur in Windows. Event Viewer is used to view the log files. Windows directories are C Windows documents and settings, users, program files x86, and users, username, and documents. Index.dat used by Microsoft Internet Explorer, not in Microsoft Edge. Stores web addresses, search queries, recently opened files, use Windows Washer or similar utility to view index.dat. Windows files and permissions. When copying and pasting on the same partition, files and folders inherit the rights of the folder they are being copied to. When cutting and pasting, moving files and folders retain the original permissions if they are on the same partition. Windows files and permissions. As Mac refers to three critical properties: file modified, data is as shown by Windows indicates that there has been a change to file itself. File created, data the file was created date file was created on the volume does not change when working normally with the file. File accessed, date file was last accessed. Access can be move and open or any other simple access. Registry, the computer hardware configuration, multiple users and preferences, program shortcuts and property sheets. Remote administration through network. The Windows registry looks like this. OS Forensics user activity looks like this. Shim cache looks like this. And BAM looks like this. In this lecture, we have discussed Windows details, evidence in volatile data, Windows swap file, Windows logs and directories, Windows registry. So let me finish the ADS and unallocated slack space analysis to conclude this lecture. Analyzing unallocated space, slack spaces, and alternate data streams or ADS is crucial in digital forensics, as these ADS can contain valuable evidence that may not be readily apparent through standard file systems analysis. By recovering deleted files, examining residual data, and uncovering hidden data streams, forensic investigators can gain a more comprehensive understanding of past activities on a system. This can be particularly important in investigating data breaches, malware infections, and other security incidents, where malicious actors may attempt to hide or delete evidence of their activities. By employing specialized tools and techniques to analyze these often overlooked areas, digital forensics professionals can uncover critical evidence that may be instrumental in resolving investigations and bringing perpetrators to justice. So, this is significant. I would suggest you to read this in totality in more depth. Digital forensics relies heavily on the intricate details of the Windows operating system to uncover and interpret evidence crucial for investigations. Understanding the NTFS file system includes its metadata master file table and features like alternate data streams is essential for recovering deleted files, tracking file activities, and detecting hidden data. Analyzing volatile memory provides real-time insights into active processes, network connections, and potential malware infections that might not be captured through disk-based forensics alone. Investigating, allocating, and slack space allows for a recovery of remnants of deleted files and other artifacts, while examining Windows swap files can reveal temporary data that was swapped out of RAM, providing additional context of evidence. These detailed analyses are vital for reconstructing events, identifying unauthorized activities, and ensuring the integrity and admissibility of digital evidence in legal proceedings. Hopefully this helps. See you in the next lecture.